Hello student, today we are going to see full gravitational formula and simple tips to memorize the formulas. Okay, the first one, gravitation, universal law of gravitation. F is equal to g times of m1 m2 divided by d square. M1 is mass 1, m2 is mass 2 and d is the distance between the two objects. Okay, so you can take it like this. It's called universal law of gravitation. Okay, the next one, what is g? G is a universal law of gravitational constant. Okay, so this one is a force, this one is a universal law of gravitation. Okay, so Newton meter square divided by kg square, Newton meter square divided by kg square. Okay, so because force unit Newton, distance unit meter square, kg, mass is kg square. Okay, you can modify formula, you will get g value. G value is going to be 6.67 into 10 power minus 11 Newton meter square divided by kg square. It's a constant value. Okay, the next one, d-dimensional formula. If you are doing solution for this, if you are substituted what is a Newton value, you will get the dimensional formula m minus 1 L cube t power minus 3. Dimensional formula for capital G, universal gravitational constant you will get. Okay. The next thing we are going to learn is a gravitational field. Okay, yeah, gravitational field. Okay, E we can call as a gravitational field. Gravitational field always force per unit mass. We can take it as a gravitational field. From this formula, if you are divided the mass, you will get as a G times of m divided by d square. Okay, d square can be modified with r square also when it is on the surface of the earth. Okay, when it's going to be modified with r square. R is the radius of the earth. Okay, it is only applicable when we are taken as a radius of the on the surface of the earth. Okay, the next one, gravitational potential energy. Energy unit we can call as a joules. Okay, it's going to be minus g times of m1 m2 divided by d. Okay, otherwise you can take it as a r also. Okay, universe work done is equal to energy is equal to force into displacement. Okay, so in this formula, if you are making one displacement, means displacement square will get cancelled, you will get like this formula. Simple tips you can learn to memorize this value. Okay, the next one, gravitational potential. Gravitational potential is potential energy divided by per unit mass. Okay, if you are removing in this formula one mass, means you will get as a minus g m divided by r, or d also you can use it. Okay, it is called a gravitational potential energy. Okay, the next one, see, the next formula, the gravitation, small g value. To find small g value, it's going to be gm divided by r square. Okay, g is a universal gravitation constant, m is the mass of the earth, and r is the radius of the earth. The value of small g is going to be 9.8 meter per second square. Okay, it's going to be the gravitation value. Okay, now the gravitation at some height. Okay, the object at some height. So it's going to be g times of 1 minus 2h divided by r. Okay, gravitation at some height. Same thing, if you want a depth, gravitation at depth is equal to g 1 minus 2h divided by r. Okay, height and depth will be equal. Okay, when height and depth gravity will be equal when you are making, sorry, this will be d. Okay, this will be d. Sorry, 2 won't come. Okay, when you are making this 2 is equal at one point, means you will get as a d is equal to 2h. Okay, so I'll explain with the problem. If a height 2 kilometer, okay, some gravity will be there. In depth, how much depth the same gravity will be produced? No, 4 kilometer, because height we are taken 2 kilometer, the same gravity will be produced depth as a 4 kilometer. Okay, that's a relation. The next one, orbital escape velocity, it's going to be root times of 2g. It is going to be r. G is the gravity, r is the radius. Okay, the next one, orbital velocity. So 2 won't come, it's the same formula, it's gr. Okay, 2 won't come. Okay, the next one, next formula, the total energy. Total energy we can take it as a kinetic energy plus potential energy. Kinetic energy of mv square, potential energy is going to be g times of m1 m2 divided by r square. Sorry, r, only r will be there for potential energy. Okay, the next, what is mv square? You can make it as a centripetal force is equal to gravitational force. Mv square r is equal to g times of m1 m2 divided by r square centripetal force is equal to gravitational force. R will get cancelled. So mv square I can get as g times of m1 m2 divided by r. If you are substituting this formula here, means you will get what is a total energy. Total energy is equal to minus g times of m divided by 2r. Just a solution. Okay, I given as a simple trick. You can use it the same trick to find the answer. Okay, the total energy I got. The next one, the relation of time period and radius of the orbital radius. Okay, actually time period t square is equal to 4 pi square r cube divided by g times of mass of the earth. Okay, time period and radius relation. Okay, this is a very important relation. Okay, how we got this time period and radius relation? There it's very simple. So mv square by r, centripetal force, is equal to gravitation force g mm divided by r square. Okay, this get cancelled. Velocity in circular motion, velocity is going to be 2 pi r divided by t. Okay, this r square will get cancelled. Velocity is going to be 2 pi r divided by t whole square of this is equal to gm divided by r. So finally, if you are modifying this, 4 square pi square r square, this r will be together, r cube will be there, gm divided by t square. Okay, so 4 square 4 pi square r square divided by t square is equal to g m divided by r. So if you want t square is equal to 4 pi square r cube divided by it's going to be gm. So t square is directly proportional to cube of radius. Okay, the next one, weightlessness. When the gravity is zero, when the acceleration due to gravity is zero, weight is equal to 0 Newton. Okay, it's going to be happen at the center of the earth. We can call as a weightlessness. Okay, the time period of geostationary satellite is called 24 hours. Okay, this is a very important point you required in a gravitation chapter. Thank you.